Thank you guys for having me. I love these tiny confs. I think they're really awesome. It's a great opportunity for the entire community from all over the world to get together and talk about the things we love, like Angular. So yeah, today I'm going to talk about refactoring made easy with component testing. And for those of you who don't know who I am, who the stranger is talking, my name is Jordan Powell. I'm a Google developer expert in Angular, and I am a developer experience engineer at Cypress.io. And you can follow me on Twitter at JordanPowell88. Today, the agenda is going to be pretty straightforward. We're going to just kind of talk high level why refactoring and like what is the value in it? Why do we do it? Why don't we do it? That type of thing. And then going to give a practical example of refactoring and how it pertains to testing, so you can kind of see the sort of do's and don'ts with when it comes to that. So before we get started, I always like to answer the why, like why is this important, and sort of do a definition of what exactly it is we're talking about. So what is refactoring, right? It's something we've probably heard of. It's probably something we've all done, but sometimes taking a step back to understand truly what it is really important. I found this definition I really enjoyed, and basically it was saying that refactoring is the process of restructuring your code while not changing the original functionality. And that's the important part here, is that when we make changes during refactoring, we don't want to cause any sort of side effects or regression in our actual functionality of the code. And so then the goal of refactoring is to improve the internal code of our application by making some small changes without altering the code's external behavior. And this is the important thing I want to highlight here, is that we're changing internal code without affecting the external behavior. And that is really the main crux of refactoring and really the challenge. And that's where we're going to talk about how testing can, when done right, can really benefit for this type of refactoring. Refactoring helps improve your code by making it more efficient. That's because, like, when we refactor, you make your code more efficient, right? And so maybe there's performance issues, maybe there is just some general compilation things going on. When you refactor, one of the goals is you want to try to make your code be more efficient. We also want to make it more maintainable, right? So oftentimes we write code and it makes sense when we first build it. We get this sort of, we don't want to have code that's unmaintainable, right? And so refactoring is sort of the mechanism that we sort of can use to make our code more and more maintainable as time progresses, and more reusable. I've certainly have been guilty of sort of over architecting or maybe prematurely abstracting code in the past. And I like to generally try to stick to the Agni principle. You ain't going to need it. So I try not to make things reusable unless I think there's a definite need to make it reusable. But oftentimes if we follow that principle, what doesn't need to be reusable today may change over time as requirements change, as new features get requested. Code that wasn't reusable initially may need to be reusable in the future. And so that's where refactoring is a great mechanism for going about making code reusable. And we'll talk about sort of in a practical standpoint what that means in a second. And more cleaner, right? Like, no one wants to live in a dirty house. And we certainly don't want to work in dirty code bases. So the cleaner we can get our code, the more just generally happier it is to work in the code base, and it can really improve velocity of your code base as you progress and keep working on it. So when should code be refactored? This is an important question, and it does depend, but these are dependent upon your team and various factors. But these are some of the things that I like to recommend. So when to refactor, one sort of approach is to do it after deployment. And this may seem strange at first, but one approach you can take is basically after you deliver a feature, before you move on to the next, maybe the next sprint or the next feature or the next task, basically revisit the code you just shipped. And at that point, it's a great opportunity to see, is there any sort of way we can make this code cleaner? Can we refactor it in any way that would maybe add some quality of life to the code base? And the important thing about this is that if you do it after deployment, you not only get to ship the feature and get the super you can ship, the quicker you can ship a feature, then the sooner you can get feedback from users about the value it delivers, or any feedback you may see that may be valuable to the product itself. And then if you refactor after the fact, it then gives you the ability to while you haven't switched context to the next thing, you can still think about, okay, now that I've shipped this, I'm getting feedback. How can I then take that and while I'm still have the sort of general mental model and context of the problem, I can then think about refactoring before I move on to the next thing. So that is definitely one approach you can take when to refactor. Another one I like to do is before new features or bugs. So as new features get requested, new bugs get filed, and you go to work on them, oftentimes refactoring before you begin the work can be a very valuable approach to taking. And testing is important to really all of these, but this is definitely a strategy if your teams are not necessarily bought in or really bought into the value that refactoring gives. Doing refactoring of the code that's part of delivering the feature or a bug can be a way you can sort of kind of sneak it in without and you just kind of maybe allocate that as part of the budget for the actual issue or the bug. And that's a great way you can sort of do refactoring without sort of getting not necessarily permission, but sort of this big bought-in buy-in to doing refactoring. And then the other thing is just make it a part of your regular part of your software lifecycle. What I mean by that is, I've worked on teams before where it was, at the end of every sprint, maybe there was a day or two where it was dedicated to do any sort of quality of life improvements, refactoring, anything like that. As well as I've been on teams where basically a certain percentage of sprint work was allocated to doing sort of quality of life refactoring and things like that. So I guess no matter what it is, or maybe it's every quarter, or I've been on teams where every December at the end of the year when the business was kind of slow, they use that time to do refactoring. I think that just having a plan for how to implement refactoring is important. And I would say then beyond that, the more you can do it on a regular basis in a smaller incremental way, the more value it's going to deliver, because the longer you wait to refactor, the bigger the mess it's going to be. And it's generally going to work better if you can do it in smaller instances. So let's talk about best practices when it comes to refactoring. So like I said, let's plan for it. So having a plan for when you plan to actually do refactoring is important, whether it's at the end of every year, or if it's maybe every sprint, or before every ticket, or after you deliver a feature. No matter what the plan is, have a plan, because if you don't plan for it, at some point you're going to have to pay the cost of technical debt, and you're going to have to actually go in and you're going to have to actually pay that cost at some point. So it's much easier to pay in little incremental bits along the way, instead of pushing it off into one massive refactor later down the road. Another best practice is to refactor first. Like I talked about, doing refactoring before you implement new features, things like that. That's definitely can be a best practice. Small steps. So like I said, the smaller refactors, the better. No one likes massive PRs that they have to review. So the smaller steps you can take, the better. And the larger the refactor you take or you make, the the more you increase the chances that you're going to cause regression into your project. And so that's where smaller steps is always better. And my favorite thing is test often, right? Testing is a very, very important part of refactoring. And maybe it's the part where really it shines the most. And so having good tests is and testing often when refactoring is really, really important. And we'll talk about that in a second. But then and fix defects separately. So oftentimes when you're refactoring, you actually find code that's maybe unnecessary or even code that's or defective parts of your application. I generally try to refrain from fixing those things alongside the remember, refactoring is not intended to change any of the external behaviors. It's only meant to change the internal implementation. And so fixing those in separate PRs and separate, maybe even separate issues or something is something I would definitely recommend. So that way you're not causing regression, and then you can then rely upon your tests for fixing things like that. Okay, so to recap, the goal of refactoring is to improve the internal code by making small changes without altering the code's external behavior. And again, external behavior is really the important thing here. And I'm gonna get into what I mean by this right now. So last week I was on the NX live stream, and we were talking about Cypress component testing and their new feature testing. And this guy, Mr. Leg Squats himself, Zach DeRosa, he had said something that I thought was really, it was really, really profound. And I don't even know if most people caught it, but he said that the only interface that matters is the DOM. And it was meant to be a little bit of a hot take, but the cool thing is that it's actually really, really relevant, especially when it comes to refactoring. And what I mean by that is how we traditionally have tested our application, especially when it comes to components, is we would basically take a component and then we would unit test the methods of that component using Jest or using Karma or something like that. And then that component would then get compiled and then shipped into the DOM. And then we'd ask ourselves, like, okay, do we feel confident that the changes we made to our methods that we unit tested still work? The problem is that if we change the internal implementation of those methods, our tests then break. So then we have to change our test to accommodate those changes. And then it's very easy to lose confidence that the actual changes in the DOM don't have a side effect for our users. And so the thing that I love about Cypress component testing is that I believe it's a better way to test your components, because it takes the DOM and it puts the component inside of it. And then what you end up doing is you end up testing the actual DOM itself. So then it doesn't matter the internal changes that you make to the component itself, because you're testing the external part of the external behaviors and sort of the interface that users have with your application via the DOM. And so that's why I think when he said that the only interface that matters is the DOM, I think there's really value in that. So sort of in summary, test type and test quality are really important when it comes to refactoring. And let me just show a real quick example here of what I mean. So let's go here. Okay, cool. So here I have an application. Let me just serve it real quick. Actually, I'm not going to serve it. I'm going to run Cypress and on one tab, and then we're going to use component testing, and we'll launch it in, let's do Electron. Ignore this error. It's because the Angular 16 isn't fully landed yet. So we have this application that basically is a login component, and we have this login form, and it does lots of various different handles, validations, and so forth like this. Then we have something simple like a button, and then we have like this welcome screen. So it's pretty straightforward. But as you can see, it's basically just like a sign-in welcome like a welcome screen, right? And so then I also have in the same exact application the Angular Karma tests, and this is basically doing that the type of testing I was telling you how we normally do, where we unit test the internals of our component. And so the thing that I wanted to highlight is, so we have here the sort of the top is the new way, the bottom is sort of the old way of doing it. And let me zoom in here and let's take one of these examples. So let's start with something. Let's go to our app component, right? And let's go here and let's actually refactor it to use signals. And so if we go to here, we will see we have a couple properties is auth, username, and error message. So let's change those to use refactor it to use signals. And the important thing is we have tests that are testing up top. We have the external behavior. Here we're testing the internal implementation. And so here, if I were to change this to signal of false and signal of an empty string, and let's do single signal of an empty string. We're then going to have to change a few of the internal things where we set the properties. We're going to have to, instead of assigning this, we're going to set the message here. We're going to do the same thing here and same thing here where we're setting these. Live typing, and one last one down here where we have this, right? So if I save this now and rerun this my new one is failing because, well, because my template is broken. You'll notice down here, this still says it's passing. If I look at the output, it's actually erroring, but the visual, like the actual test runner itself is saying it's still passing. So it's sort of like a false negative, which or a false positive, which is like the worst thing you want in testing. And then if I go to here, if I go in, you'll see I need to change the implementation of these. So I invoke these and do this. And then here, so basically I'm just calling the signals instead of those public properties. If I now press save, my test now passed, right? Which is the important thing is that I refactored this component, the internals of it, and I didn't have to change any of my tests, which is really, really important when it comes to refactoring. We could do this for other parts of our application. Let's see, we have a login form here. Ooh, not that. Let's do the same thing where we have a couple of values. Let's change this to signal. And same thing. Can't type signal today. I don't know if that's some type of signal that I need to. Been a long week or something, maybe. But okay, so then here, let's do both of these together. We're gonna oops. Dot set. Do this. And then we need to invoke both of these, and same thing here. I think that is all this. Again, let me go to the actual login form test so we can see this. And most of them are passing except for, looks like there's probably something in our template that needs fixed. And that's because these error messages are not working because this is not set. So now if we rerun these tests are all passing. And again, this still like says it still says it's like working. I refresh this, it says it's working. I could then restart the test runner here, and it will then just give me this. So again, we're not getting valuable feedback from this type of testing. And that's what I love about, again, component testing, because it's in the DOM and because we can test the behaviors of it, the external behaviors, the internal implementation doesn't really matter. So I think that I am right at 20 minutes, I believe. But yeah, so that is the spiel. I hope this was valuable for you guys. Here is a little feedback thing if you guys want to give me some feedback how I did, and Cypress will send you some swag, I believe, which is pretty cool. And then that's it. Thank you guys.